Hi, Sam. And we are in the
3D printing space.
All right, in the Geneseo Experimental Design?
Geneseo Experimental Space, yeah.
Experimental Space. And this is at SUNY Geneseo. And we are going to be printing the 5 regular polyhedra. And I'm absolutely astounded at how easy this is. It's going to be super fun. And this is the bamboo program that's driving the printer, and it allows you to do all kinds of fun things like change scale and define many other parameters, I'm sure.
Yep, so you can scale it to make it bigger, you can change it to like what face you want it to put on, arrange it, so then once that's all good, you send it, loads it.
Kind of still purging a little bit, but...
Okay, here we go. We can see some yellow plastic spooling down into the printer body. So it's creating a little reservoir for itself. And then it's going to go to it, and we're going to make a yellow cube. What's going on here, Sam? With it dancing back and forth.
It's leveling itself out.
Okay, so it's calibrated.
Yeah, it's calibrated, yeah.
Got it. All right, it's warming up and it's almost ready to go. It's done calibrating, and any moment now, we will be printing. Oh, look at that. There it goes. We're starting the base of the cube. And now it's filling in. Go, bamboo, go. Okay, here we go with the second layer. And it's doing it at a 45-degree angle to the first layer as it fills it in. Pretty cool. It's doing a grid rather than doing a linear progression. Obviously, we haven't given this the most challenging of shapes to start with, but it's having fun, I can tell. And what Sam is doing over here is getting the kinks out of the process because it wasn't spooling correctly, so she's making sure that we've got a nice, even thread that's going into the machine. So it's actually making this a lattice rather than solid because it's a more efficient use of materials, but the outside of it will all be solid squares. Looks like it's putting on the second layer of the top surface. Et voilà, a cube. We're going to start printing the next file because we're done with the cube, and I believe we're on to the dodecahedron. And this is Kayla. Yes. Interesting thing about the dodecahedron is that its volume to external surface area is greater than any of the other regular polyhedron, so it is in and of itself somewhat spacious. All right, so here we go with the base layer of the dodecahedron, and you can see if you look closely that it's actually starting with a pentagon, because the the dodecahedron is 12 pentagonal faces. So this will really be interesting to see how it fills this one out. Okay, we finished the base layer of faces, and now you can see that the angle has changed on the faces themselves, and it's starting to go back toward the center. So we're up to the second tier in terms of the edges that it's actually creating. But it's continuing to fill in the honeycomb matrix, and the primary work that it's doing is the internal honeycomb matrix that lends its strength and support. Now it's completed the internal volume and is printing the top surface. Et voila, a dodecahedron. So we're about to start printing the icosahedron, which is going to be blue, and it's spooled and loaded, and then it's going to go through its process of calibration, and in a little while it will actually start printing. Okay, we're started on the icosahedron, and you can see that it has a triangular base. Well, maybe it's not quite so obvious. But it's already started, it's done with the surface, and it's starting on the first faces that are above the surface level. And this particular polyhedra has 20 triangles as its sides. The icosahedron is progressing along nicely here with its triangular infill and its triangular faces on this printer. And Kayla is loading a green spool into its neighbor so that we can start printing the octahedron. And this guy's going to do its thing and calibrate, etc. And then pretty soon it'll start printing too. This is where we are so far with the octahedron. It has 8 triangular faces, and it's just past its surface layer for the base and proceeding to start making some triangular faces on the sides. And here's where we are so far with the much more complex icosahedron. And you can see it starting to take shape. Oh, this is what happens when it accidentally picks it up and moves the original shape. Okay, calibration procedure for the second try at the icosahedron. The most complex, but still simple, in terms of shapes, of the regular polyhedra. And here's how we're doing with the octahedron. It's progressing nicely. And now we have an octahedron. Here's the beginning of the tetrahedron with its triangular base. There we have it, an icosahedron. So the tetrahedron is a three-sided pyramid with the fourth side as the base, formed of a total of 4 equilateral triangles. And we're getting up to what would be the capstone on this three-sided pyramid. And you can see that the spacing is getting much, much tighter as it approaches the apex. A tetrahedron.